episode 4 of the World of FPGA podcast. In this episode, I would like to show which manufacturers are active in the FPGA world and which components they offer. Welcome to the World of FPGA podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. There are several players in the field of FPGAs. This list is without a real evaluation according to their market power. I just want to show you the FPGAs and their areas of application of different manufacturers. And here's now the roundtable of introduction. We will first start with Xilinx. Xilinx was founded in 1984, and there was an acquisition of AMD 2020 announced, and now Xilinx is a part of AMD. Currently, the 7 series is the active series of FPGAs from Xilinx, and there we have on the low end side the Spartan 7 and the Arctic 7 components, FPGAs. In the mid-range we have the Kintex 7 FPGA, and on the higher end we have the Vertex 7 FPGA. And with low, middle and high end, I mean on the one hand the inside the FPGA, the speed of calculations of flip-flops, and also the numbers of lookup tables and so on, but also the price. So on the low end, Spartan is very cheap, and on the other side, Vertex, well, there are devices which cost the same as a mid-range car. So if you have very complex systems with high amount of calculations, well, then you will maybe need a Vertex. And Xilinx offers also a system on a chip. It's called Sync, and it's a mixed up of 1 or 2 ARM cores with programmable logic from also the 7 series. On the one hand, the Arctics, or in a higher range from the Sync, there are also components with the Kintex as programmable logic. So there's 2 parts on one die, and you can use both if you want, or only parts of them. From all of the 7 series FPGAs, there are also the ultra scale variants. Some of them have also ultra scale because they have a newer design in silicon, so it's smaller transistors, and so it's higher speed and so on, and a higher price maybe also. Some of them have also some radio frequency components, so you can directly go into high frequency basebands. And some of them have also some coprocessors and graphics engines and other funny stuff. And from Xilinx, just as a side note, there are also CFLDs still available for some designs, but Xilinx is more focusing on the higher end market. So if you searching for smaller devices, maybe there are other companies more interesting for you. The next company is Intel. Intel was founded 1968 and acquired Altera in 2015. So Intel has didn't develop their own FPGAs. They're buying the company Altera and integrate them in their portfolio. And now they are working also on FPGAs. And there are some series. We have the Agilex FPGAs. These are more on the mid-range. This is a FPGA with also system on a chip. So like in comparison with a Sync. Then we have the Stratix series. It's the high-end performance FPGA. Well, maybe you can compare it to a Vertex or a Kintex, maybe. Yeah. This is Stratix. Then you have the Aria FPGA. This is more in the mid-range and is more for performance and for power efficiency. Then we have the Intel Max series. This is a special one because it's a non-volatile architecture. I haven't mentioned this before, but until this device, all other devices I have announced here, maybe not the CPLD from Xilinx, but the FPGAs from Xilinx and the other FPGAs from Intel have all a volatile SRAM architecture. And they need an external memory to boot and to start the FPGA, whatever the thing will do. So the Max series is the only one which is not volatile and starts direct out when you switch on the power supply. And then also the Cyclone series. It's a more low power, cost sensitive thing. If your design needs this, then you can switch to the Cyclone series. The next company is Lattice Semiconductor. Lattice was founded in 1983, and they have also some different FPGAs. On the higher end, high speed end, we have the Certus FPGA, or Certus, whatever. You will find it on the website from Lattice. Then a more general FPGA, and this is, you can use for many different applications. The ECP5 FPGA, there was also ECP3, ECP2, and ECP, and so on. The ECP5 is the newest version in this family of FPGAs. For more video applications, there is an FPGA called Crosslink. It is you can use it extremely good for video applications where you have MIPI interfaces or DSI, CSI interfaces and want to do something video things. And if you search FPGA with very low power consumption and also with very small footprints, then there is the ICE40 FPGA from Lattice, a good choice. Lattice has also non-volatile FPGAs, the Mach and Mach XO FPGA line. And it has also many interesting security features like encryption and so on. And they're also working on an SoC. At the moment, I'm unsure if they have released it. Maybe I have to do a look later on. So also Lattice will have an SoC later on, or they have now one. I will have a look on this. The next company is Microchip. This was an acquisition of Atmel in 2016. So Microchip has bought Atmel in 2016 and also bought Microsemi in 2018. Microsemi was formerly Actel, so Actel was then Microsemi, and then it is Microchip, and Atmel is Microchip. So Microchip has bought many companies in the last years. So more or less everything is Microchip, and they have integrated their chips into their own portfolio. Just they have normal FPGAs, a long list of FPGA. So I haven't searched out all the names. They have from Microsemi also the SoC FPGAs, so system on a chip with a processor core and the programmable logic core. And two very interesting FPGAs I want to announce here in this list, and they are both from Microsemi, if I'm correct. The one is radiation tolerant FPGAs. So these are FPGAs you can use, for example, in satellites or in other systems which maybe get radiation from the sun. And they have FPGAs with the technique called anti-fuse. And anti-fuse FPGAs are one-time programmable FPGAs. So it's in a little bit in the direction of ASICs. You can program one time your function into this FPGA and then this device is locked. The next company in my list here is Efinix. Efinix was founded in 2012, and if I'm correct, heard it correct, there are people from Lattice have created their own company and call them Efinix. And Efinix is a fabless FPGA manufacturer. So they have no fab who creating or build up their wafers. So they are just let other companies build their FPGAs. And there has a little bit different structure inside their FPGAs in comparison with Xilinx or with Lattice. They have a mix of slides and matrices. Maybe I will go later on a little bit deeper into this in a later episode. It's fascinating because it's just another way how FPGAs can build up. And they have two FPGAs in their portfolio. It's the Titanium FPGA and the Trion FPGA. And they also give for other semiconductor developers the FPGA as an IP core out for other chips. So a manufacturer can integrate the Efinix FPGA as IP core in another chip. Then there's a company called Achronix, founded in 2004, and they have a very high speed and high bandwidth FPGA called Speedster 7T, and they also have FPGAs as IP core and also have a fabless FPGA. Achronix is also a fabless FPGA manufacturer. It's the same as Efinix. They have both no own fabric. No fabric. So, and the last company, and was some years ago a little bit surprising for me. It's the company Cologne Chip. It is a company founded in 1994 in Cologne, Germany. That's the only FPGA company in Germany. All other companies are outside of this country. Well, Cologne Chip was first known as a telecommunications chip specialist. They created a chipset for ISDN. It was a telecom standard here in Germany, and now they have the gate-made FPGA developed. And the funny thing here, it's a scalable design because they have cores, FPGA cores. That's a little block on a die, or this is one die. And the idea is, if I have understood it correctly, you can later saw one die out of the wafer, or you let two dies connected together, or you let 4 dies connected together, or 9 or 16 or 25 cores in one block. And power and IOs are routed through the FPGA to the FPGA dies on the edge, and there the bond wires get connected. So you can scale your chip from 1 to 25 cores in one package. That's a quite interesting design, how this can be made. And if I'm informed correctly, they are also a fabless FPGA manufacturer, but they have a company I think also in Germany, who built the wafer and doing the packaging. They are now on the market, and since some month, I think they have also evaluation kits available. So this was my long list of 1, 2, 3, 4, 5, 6, 7 companies who build up FPGAs, and with some additional information about these companies. Yeah, next week we'll go down to business. We will look into FPGAs and their architecture. In the show notes, I will put the links to all of the companies here, and there you'll find also some more informations. And the show notes can be found at world-of-fpga.com/WFP004. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye here, next time, your David Kirchner.